Hello friends, now we have to solve this given differential equation. Here you can see that this equation can be written as d2y by dx2 plus 4 times dy by dx minus 12y equal to x minus 1 times e to the power x. You can see here this is the highest order differential coefficient. Highest order differential coefficient, this is the second order. So this is second order differential equation. As you can see here, the coefficient of dy by dx is 4, which is constant. Coefficient of y is minus 12, which is also constant. So this is second order first degree linear differential equation with constant coefficient. So you can see this is the second order linear differential equation with constant coefficient. You can see here this is the second order linear differential equation with constant coefficient. Because here the highest order derivative is d2y by ds2, so the order of this differential equation is second order, and the coefficient are constant. Here is 4 and here is minus 12, so this is the second order linear differential equation with constant coefficient. So for solving the differential equation, you know that we put d2 by dx2 is equal to capital D square and d by dx equal to capital D. So this equation can be written as d2y plus 4 times dy minus 12y is equal to x minus 1 times e to the power x. Now with taking common here y, so we get d square plus 4d minus 12 times y equal to x minus 1 times e to the power x. Now we form auxiliary equation. So for forming auxiliary equation, we replace small m in place of capital D. So this will be m square plus 4m minus 12 equal to 0. This is the auxiliary equation. Now we find roots of this auxiliary equation. So you can see here the factor is m square plus 6m minus 2m minus 12 equal to 0. Taking common m here, so we get m plus 6. Now taking common 2 here, we get also m plus 6. Now taking common m plus 6, we get m minus 2 equal to 0. So the roots of the given second order linear differential equation with constant coefficients are minus 6 and 2. These two roots are distinct. So the complementary function can be written as c1 e to the power m1x plus c2 e to the power m2x. Here c1 is m1 is minus 6 and m2 is here 2. So the complementary function is c1 times e to the power minus 6x plus c2 times e to the power 3x. Now we find the particular integral of the right hand side. So particular integral is equal to 1 upon fd, and fd is here d square plus 4d minus 12 times of x minus 1 e to the power x. Now we find the particular integral of the right hand side, and the right hand side is x minus 1 times e to the power x. So we write 1 upon fd. Fd is d square plus 4d minus 12 and x minus 1 e to the power x. Now we find the particular integral of this. So you know that the formula for finding particular integral of e to the power ax times v is here e to the power ax 1 upon f d plus a times v, where v is a function of f. You can see we have to find the particular integral of e to the power ax multiplied by v. Always we replace d plus a in place of d and take outside e to the power ax and find the particular integral of v. And v is the function of x. You can see here this is v. So when we take this e to the power x in outside the particular integral, we replace this d by d plus 1. You can see here from the above formula, when we take this e to the power ax outside the particular integral, we replace this d by d plus a. Here a is small a is 1. When we take this e to the power x in outside the particular integral, we replace this capital D by d plus 1. Now we solve this. Here you can see d plus 1 whole square, this is d square plus 1 plus 2d, and this is 4d plus 4 minus 12 x minus 1. So you can see here d square plus 4d plus 2d, this is equal to 6d, d square plus 6d here, and this 4 plus 1 5 minus 12, so this is minus 7 times x minus 1. Now we find the particular integral of x minus 1. So for finding particular integral of x minus 1, we that we take common here minus 7. So minus 7 common here, and 1 plus d square plus 6d divided by minus 7 whole power minus 1 x minus 1. You can see here when we find the particular integral of x to power x to the power, some power. So some power of x. So first we divide taking common here minus 7. So minus 7 will be divided in d square plus 6d, and take in the numerator, this will be written as 1 plus d square plus 6d divided by minus 7 whole power minus 1. So e to the power x upon minus 7. Now we expand this by the expansion of 1 plus x whole power n. You know that expansion of 1 plus x whole power n is 1 plus nx plus n minus 1 upon factor 2 x square and so on. This is the expansion of 1 plus x to the power n. You can see here n is here, n is minus 1 and x is this one. So from this expansion we expand this, and you know that when we expand this, always we take those terms in which power of d and power of x are similar. Here the power of x is 1, so we take only those terms in which power of d is 1. So 1 plus nx, n is minus 1 and x is d square plus 6d divided by minus 7. Neglecting higher order term of d, because when we take d cube, d4 and differentiate this one x minus 1, so it will be 0. So we take only those terms where the power of d and x are similar. Now this can be written as e to the power x divided by minus 7, and this minus minus plus here, and we take only 6d by 7. And neglecting this d square, because when we take d square and differentiate x minus 1 2 times, we get 0. So we take only term 6d. Now we multiply this x minus 1 in bracket, we get e to the power x minus 7. Here we multiply x minus 1 plus 6 by 7, differentiation of x minus 1. So this is e to the power x on minus 7, x minus 1 plus 6 by 7, 1. And we differentiate x with respect to x, we get 1, and differentiation of 1 will be 0. So this is 6 by 7. Now we taking common 7 here. So we get minus 49 and we get 7x minus 7 plus 6. So this becomes minus times e to the power x divided by 49 and 7x minus 1. Now we write general solution of the given differential equation. Now we write the general solution. This is equal to y equal to complementary function plus particular integral. And the complementary function is c1 times e to the power minus 6x plus c2 times e to the power 2x, and particular integral is e to the power x divided by 49 times 7x minus 1. So this is the general solution of the given differential equation. Thank you.